Hello and welcome to Engineers Mindset Academy. So in today's video, we are going to be talking about the concept of free body diagrams, and we are going to use this particular question on the board to explain what a free body diagram is. Now, a free body diagram is a diagram of forces showing all hidden force in a given system. It is simply a diagram of forces which shows all hidden forces in a given system. For instance, I have this question on the board. Let's take a look at the question. It says, three forces act on the bracket as shown. Determine the range of force P such that the resultant force does not exceed 2.4 kilonewtons. So we have this force on this bracket. If we are to solve a problem using this, we cannot solve this problem on this bracket, although it can be solved. But then it is always important to outline the free body diagrams to show all the hidden forces in what this bracket are shown on the board. So that's the essence of free body diagrams. Now, in two dimensions, what's the free body diagram? Simply your x and y coordinate Cartesian system. So you actually plot out your x and y coordinate Cartesian system, then bring out all the hidden forces on the bracket and show it or display it on the coordinate system. It's as simple as that. So to solve this problem, the first thing to do is to outline your free body diagram. The short form is FBD. And I said in two dimensions, your FBD is simply what? Simply drawing your vertical and your horizontal components, your Cartesian coordinate system. This is your FBD. Whereas this represents positive y, this represents positive x, and this represents negative y. You already know this. This is negative x. So let's now represent all the forces that we have on this system. If you look carefully, this is a horizontal line which carries this force P. So which means this force actually what is purely on the horizontal component, a pure horizontal line which carries force P. So you can simply outline that force to be somewhere around here. So you can call this force P, something like this. So this is what you have. So this means now that if I draw an imaginary line here, okay, so you can see that this has automatically become what? My y-axis, and this becomes my x-axis. So which is what I am doing here, representing this information on what? The free body diagram. Okay, now remember also from this now the origin. From the origin we have a force of 3 kilonewtons. So you also represent it here, a force of 3 kilonewtons from the origin pointing out. This is 3 kilonewtons. And then we have a force of 0.8 kilonewtons from the origin pointing this other way. From the origin as well, we have a force of 0.8 kilonewton. It's as simple as this. Then we have an angle here to the horizontal, 60 degrees. We also indicate that angle here. This is 60 degrees. Now, mind you, from this point to this point is 90 degrees. So let's trace it and see. From this particular force to this other force is 90 degrees. So from here to this point was given earlier as 90 degrees. Okay. We have it here to be 90 degrees. Let me just put it somewhere. Okay, let's just work with it here. Okay, so to avoid confusion, so from here to this point, I've bisected here into two. This is my y, okay, and this is my x. Now, from this force to this force is 90 degrees. But not forgetting, from this angle, from this point to this force is what? 60 degrees. We have this angle to be 60 degrees. And if here is 60 degrees, it means automatically the remaining angle here is what? 30 degrees, because angle on a quadrant must be 90. So if here is 60, it means the angle here must be 30. And again, if from here to this point is 90 degrees, and we already know now that from here to this point alone is 30 degrees, because here is 60, it means from here to this point remains what? 60 degrees, such that from here to this point becomes 60 plus 30, which gives us what? 90 degrees. So which means this angle here is also 60 degrees. And if that's the case, it means the angle here is also what? 30 degrees. Alright, angle of a quadrant must be 90. So we have this whole information. So this is what we call the free body diagram, showing what all the forces on this system. It's as simple as this. Now with this, you can now employ everything we've learned on two-dimensional force to solve for each of these forces. Okay, so let's start to resolve each of these forces in their x-axis. So I will call this 3 kilonewtons force. Okay, let me call 0.8 my first force. So F1 equals 0.8. 3 kilonewton should be what? My F2. And of course, let this P force, which I asked to find, okay, you can still leave it as P. We're asked to find the values of force P. So let's start with horizontal force. Okay, horizontal component of force. Alright, so we start with the first force, F1 of x, and that's equal to, as always, hold F1, hold the arrow of F1, pull it till it meets the X line. So if I pull this force till it meets the X line, notice the direction of this arrow, it also points where? To the right. I'm sure you already know this by now. Please, if you don't understand this, you can do well to watch the introduction video on resolution of force in 2 dimensions to properly understand what we are doing over here. Okay, so if you pull this force to meet this line, observe the direction of the arrow of this force. It points to the right, so which means it is what? Positive in the X direction. Then again, it passes through what? This angle. So this is our shortcut and it works perfectly fine. It passes through this angle 60 degrees. So we said that you multiply the force by what? Cosine of the angle it passes through to resolve it to any of the direction you want. So if I'm resolving to X, which means it passed through this angle 60 degrees, so I'm going to multiply this for 0.8 to what? Cos 60, because it passes through 60 degrees. And again, observe the direction of the arrow. It points to the right. If I pull this force here, this arrow points to the right horizontally, so which means it is what? Positive. So F1x becomes what? 0.8 times cos 60. So I'm going to punch this all at once. I'll point 0.8 times cos 60, and that will give me about 0.4 kilonewton. So this becomes the horizontal component of force F1. Next, for force F2, also apply the same principle. Hold the tip of the arrow of the force, pull it till it meets the horizontal line. Now always take note, it is the horizontal line nearest towards the quadrant, nearest to the quadrant. So you don't pull this force to this other horizontal line, no. Since this is the horizontal line nearest to this quadrant, then you pull it towards this horizontal line. If I pull this force to this X line, observe the direction of the arrow. Arrow points to the left, so which means this force is a negative force. If I pull this force to this line, this arrow points to the left when it becomes horizontally, or it becomes equal to this horizontal line. It points to the left, which makes it what? A negative force. And then again, it moves all the way from here to this point, covering this angle 60 degrees. So remember, multiply the force by cosine of the angle it passes through. So in this case now we have minus 3. So F2x is now equal to minus 3, minus because it points to the left, so it's negative component, times cos 30. Okay, so we have minus 3 cos 30. I'm going to punch this all at once. So we have this to be approximately minus 2.60 in newtons. And finally, we need to resolve force P in the X direction. So notice now, please be very careful that P already is in the X direction. Already P is in the X direction. So which means it does not make any angle to either vertical or horizontal. Okay, so since it doesn't have any angle, you can simply say P cos 0, or you simply leave it as what? P. P is purely horizontal. I told you earlier in the introduction video that forces are meant to be what? One-dimensional and not two-dimensional. So if we experience a force in 2 dimensions, we must always resolve that force to be what? In 1 dimension. So P already is in 1 dimension. It means that P of X, resolving P to the X axis, also remains what? P. It remains this force P, because it is already in the X axis, and it is positive because it is pointing to the right, so it is positive. Now, having known this, that's the resolution of all the forces in the X direction. Then we find their summation. Okay, now the next step is now to find summation of horizontal forces. Summation of horizontal forces. So we simply call that summation F of X, and that's equal to sum all the horizontal components together. Remember, F1 of X, okay, and F1 of X gave us what? 0.4 kilonewton. So you have 0.4 plus F2 of x gave us minus 2.6. Put it down. So this becomes minus 2.6 and not plus. Okay, minus 2.6, and then P of x remains P. So you put it down plus P. So this actually implies that summation f of x, or this implies summation f of x is now equal to, so 0.4 minus 2.6, that will give us minus 2.2 plus, put down your P, okay, and you can conversely write this as what? P minus 2.2. So keep this equation aside. So this is our resolution of force in the x-axis. Next is to find vertical component of force. Vertical component of force. Okay, so the same principle, the same idea. Hold the tip of the arrow of the force. Now you're pulling to the nearest vertical component in that quadrant, and the nearest vertical component now is simply what? From the origin to what? This is the nearest vertical component and not the horizontal one, not the one beneath, sorry. Okay, so if I pull this force now to meet this vertical line, observe the direction of this arrow. Observe the direction of this arrow. If I pull this force to meet the vertical line, this arrow also points where? Upward. So which means it is positive. And again, it moves all the way from here to this point, covering what? This angle 30 degrees. So which means it covers 30 degrees and it points upward, so it's positive. So F1y, resolving F1 in the y-axis, we have the magnitude of the force is 0.8. So you have 0.8, multiply this by cosine of the angle it passes through, now cos 30. Alright, so 0.8 cos 30, I'll punch this all at once. So we have that to be 0.69 kilonewton. Also, it is positive because it points upwards. Similarly, resolving force F2, which is 3 kilonewtons force, remember, to the nearest vertical line in the quadrant. And the nearest vertical line in this quadrant is what? This other one as well, and not this one beneath. So you pull this force to meet this vertical line. If I pull this force, observe the arrow of this force. Observe, do this imaginative now. If I pull this force to meet this line, this force still points where? Upwards. If I pull this force to meet this line, it still points upward. So which means the force in the vertical direction is what? A positive force. And then it moves all the way from here to this to meet this vertical line, covering what? This angle. It moves all the way from here to meet this line, covering this angle 60 degrees. So remember, multiply the force to what? Cosine of the angle it passes through. So it becomes what? So F2y is now equal to, the first magnitude is 3 multiplied by cos 60. So I will do this all at once. 3 cos 60 will simply give me 1.5 kilonewtons. I have this. Finally, we are now to resolve force P to be in the vertical direction. But take note, like I said, force P is already a one-dimensional force. Forces are meant to be in one dimension and not in two dimensions. That's the reason why we are resolving these forces. Since they are inclined, we are resolving them to what? One dimension in both x and in y. But P is already in the x direction. It's one-dimensional force. It does not have any component on the y-axis. As such, the component of P on the y-axis remains 0. It cannot be solved because P is already on the x-axis. So there's no need to put this here. And even if you want to put it, you can simply say P of y is equal to what? 0. And this is simply saying P cos 90, because the angle it takes this force P to get to the y-axis is simply what? 90 degrees from here to this point. So it's 90 degrees, and P cos 90 automatically gives you 0. So the component of P in the y-axis is simply 0. So you can either erase this or you can leave it. It's unsolvable. Alright, so the next thing to do is to sum the vertical forces together. Summation of f of y, okay, summation of vertical force Okay, we simply call that summation f of y. So we add all the vertical components together. If you do that, f1 of y gave us 0.69, f2 of y gave us 1.5, and this gave us 3. So simply 0.69 plus 1.5 plus 0. So you add all of this together, you have summation f of y to be equal to, let's add them all up. We have 2.19 kilonewtons for summation of force in the y direction. So recall in the previous video I said resultant force. In the previous video I said resultant force in 2 dimensions, always arrow is taken as the square root of summation f of x all squared plus summation f of y all squared. Always the resultant force is taken as this. And in the question, it was stated that the resultant force must not exceed 2.4 kilonewtons. So it means that resultant force is actually what? Equal to 2.4 kilonewtons. In the question, it mustn't exceed 2.4 kilonewtons. So if you have this, then let's now impute these conditions into the equation for resultant force. Alright, so from here, resultant force, which is now 2.4 kilonewtons, is equal to the square root of summation of force in the x-axis all squared, and summation f of x simply gave us here as p minus 2.2 kilonewtons. So it means we have that to be p minus 2.2 all squared, okay, plus next is summation f of y squared, and summation f of y gave us over here as 2.19 kilonewtons, so plus 2.19 all squared. You have this, so this is equal to, okay, so let's take the square of both sides just to cancel the square root. Take the square of both sides to ease the workload. All right, so we have 2.4 all squared to be equal to, of course, the square root of p minus 2.2 all squared plus 2.19 all squared. So we are simply taking square of both sides. If you do this, this square cancels this square root. So let's evaluate 2.4 squared. So 2.4 squared gives us 5.76, and that's equal to, here now this square cancels this square root, so you have p minus 2.2 all squared, okay, plus let's obtain 2.19 squared. That's approximately 4.80. Okay, so we have here 5.76 to now be equal to, so we have to expand p minus 2.2 squared. So let's expand this, p minus 2.2 multiplying by what? P minus 2.2, okay, plus 4.80. So 5.76 is now equal to, let's expand now, p multiplied by p gives us p all squared, okay, p multiplied by minus 2.2 gives us minus 2.2p. Same thing, minus 2.2 multiplied by p now becomes minus 2.2p, and then minus 2.2 multiplies minus 2.2, minus times minus becomes plus, so I have plus, then 2.2 multiplies 2.2, that gives us 4.84. Not forgetting, put down your 4 points, so this is plus 4.80. So at this juncture, I think let's send 5.76 over to this side of the equation. If I'm moving 5.76, it means I have what? Nothing left here, so it becomes 0, and that's equal to p squared, okay, minus, now let's add up, minus 2.2p minus 2.2p, that will give us minus 4.4p. Okay, I have here plus 4.84 plus 4.80. Now, if 5.76 comes over here, it becomes negative minus 5.76. All right. Okay, so we are going to rewrite this equation now, but I will start from this term, p squared, okay, minus 4.4 p. So let's evaluate this now. 4.84, 4.84 plus 4.80 minus 5.76. And that gives us plus 3.18. So we have plus 3.18, and this is equal to 0. So if you take a look at this question or this equation, we are having a quadratic equation, and which is why the question told us earlier, find the range of values of force P. So we have to solve for the values of P. So obviously, we are going to obtain two values for P. So we simply employ any method of quadratic equation, but I think the best method to employ here is the general formula for me. Alright, so I'm using the general formula. P equals minus B plus or minus square root of B squared minus 4AC all over 2A. Okay, I think this is better to solving this problem. Now, where A is the coefficient of P squared, coefficient of P squared in this case is 1. The number attached to this variable P squared is 1, whereas coefficient of P becomes B. B is equal to, the number attached to P is what? Minus 4.4. We have minus 4.4. And finally, C is a constant term, which is 3.18. You have 3.18. So we have this. Okay, so we employ the equation now. P is equal to minus, remember, minus B, and B itself is what? Minus 4.4. So this is minus 4.4, because B is minus 4.4, plus or minus square root of, we have here B squared, and B is minus 4.4. So that's simply minus 4.4 all squared, okay, minus 4 times A, coefficient of P squared, A here is 1, okay, times C, and C is equal to what? 3.18. So times 3.18 all over 2A, and A is also 1. You have this. So P is equal to, take note, minus times minus becomes plus. So I have 4.4 plus or minus the square root. Now let's evaluate 4.4 all squared from here. That gives us 19.36. Okay, minus 4 times 1 times 3.18. We have that to be 12.72 all over 2 times 1 remains 2. So this is equal to, okay, 4.4 plus or minus the square root of, so let's evaluate now, 19.36 minus 12.72. That gives us 6.64 divided by 2. So this simply implies that P is equal to 4.4 plus or minus. Let's obtain now the square root of 6.64. That gives us approximately 2.58 all over 2. Hence, P can either be, therefore P is equal to either 4.4 plus, so we have plus or minus, so which means P has two values. One lies on the positive arm while the other lies on negative arm. So let's consider the plus now. We have plus 2.58 all over 2, or we consider now the negative arm. P is equal to 4.4 minus 2.58 all over 2 as well. Okay, yeah, so for the first side, p is equal to, let's obtain now 4.4 plus 2.58. Okay, so that gives us 6.98 divided by 2, which is equal to 3.49 kilonewtons. Or P is equal to, so we consider the second arm now, 4.4 minus 2.58. So that gives us 1.82 divided by 2. So this is actually saying 1.82 divided by 2. Okay, so that gives us 1.91 in kilonewton. So it means P can either be 3.49 kilonewtons or P can be 1.91 kilonewtons. So those are the two values of P as requested or required in that given question. Alright guys, so I hope this video helps you to understand two-dimensional force analysis properly. In the subsequent videos, of course, I'll try to solve more and more detailed questions on two-dimensional force analysis. In the meantime, if you're new to the channel, please do well to like our videos, comment, share, and subscribe to your friends. I will see you in the next video. Thanks and cheers.